Sounds good. Thanks so much, Susanna, for that introduction. And I'm just going to share my screen. Let me find where I put my slides. I was enjoying your presentation so much, I forgot where I put them. 1 second, sorry. So as Susanna mentioned, oh dear, I closed the window. Give me 1 second. As Susanna mentioned, I'm based in Seattle, and right now we have Google I/O going on. And I had bookmarked my slides and then forgot where I put them. Here we go. So we have Google I/O going on at the moment. And with Google I/O this year, one of the things that we've been really trying to focus on, given the Google I/O audience, can you see my screen? You can, okay, cool. Let me full screen that. So given the I/O audience, a lot of our focus this year has really been on mobile and web developers. And so to explain a little bit about what we do is I work in a part of Google called Developer Relations, or devrel. And as the name suggests, it's developer relations. And really my mission and the mission of the team that I lead is to empower software developers everywhere in being able to use machine learning to solve the problems that they want to solve, and maybe open up new scenarios for apps that we hadn't previously thought of before, hadn't previously discovered before. So our goal then is to educate software developers, and I always like to say it, and how this whole mission began was about 2.5 years ago, when we were looking at how ML is being taught to the world. And the first question was, well, how many ML practitioners are there in the world? And when we took a look at research, the research generally showed there were about 300,000. And that was about 100,000 in the US, about 100,000 in China, and about 100,000 in the rest of the world combined. But meanwhile, you take a look at software developers, and you'd look at whatever different surveys kind of show different amounts of software developers. It's generally in the tens of millions. Last year at WWDC, Tim Cook mentioned that there were 28 million Apple developers alone. And I've been working from a rule of thumb that there are about 30 million software developers. So the mission that we set upon was, well, if we can train 10% of software developers to be ML practitioners by having ML available in their apps and giving them sufficient skills to be able to train models and use them in apps and websites on the cloud or all of those kind of things, then we'd have 3 million trained ML people, which would be 10 times the number of ML practitioners that we'd seen previously. And that's when ML can really take off. So while research and academia and folks like Google Brain and Google AI tend to focus on the huge models that have relatively few direct users, but they can have many billions of indirect users, we wanted to focus on the software developers and the practitioners who would build the apps that have thousands of users, but they would build millions of these apps. And as a result, you know, these small focus scenarios, and like I said, to maybe open up new scenarios that we've never seen before, that the general software developer can have ML as part of their toolbox. So every year we do Google I/O, and the goal behind Google I/O is to equip software developers, primarily mobile and web developers. So for the last few years, I've been running what we do at Google I/O as far as the Tensorflow and Google AI are concerned. And this year, our theme was very heavily towards cross-platform mobile and web developers. So what I'm going to talk about tonight is there were the top 10 announcements that we have in no particular order. But if you haven't been able to go to I/O and you want to know what's like the latest and greatest that we're doing in that space, then that's what I'm just going to be going over for the next few minutes. So the first announcement was really about reducing your app size. And the goal behind this one is a few things. That TensorFlow Lite, you're probably familiar with, is the runtime for Android and for iOS. But for Android in particular, what we're doing is that we're actually going to have the TensorFlow Lite runtime ship as part of Google Play services. So what this means is that you will greatly minimize your APK size because Google Play services ships to most Android phones. And as a result, the TensorFlow Lite runtime will be there. So all you have to worry about shipping is your model and not shipping that runtime as a dependency for your model. So that's like one of the big things we're working on. We announced it yesterday. We're going into an early access program. You can see the URL for that, g.co/androidml-eap for that. So if you're a developer and you want to start looking into that, you can start right away. And then the vision is that sometime later this year, probably in the early fall, like late summer, early fall timeframe, is when Google Play services, or GMS Core, as you may have heard it being called, will actually ship the TensorFlow Lite runtime. So as a result, your app will be smaller and tighter. And then, of course, in addition to that, we've been working really hard by doing many performance optimizations. There will be automatic monthly updates to the runtime when it's part of Google Play services. And in many apps, we've been seeing, like in the last 12 months alone, CPU performance on an Android phone has increased by about 50%. So obviously it depends on your app, it depends on your model, but these are some of the numbers that we've seen. So I think this is the first, like, to me, really exciting thing, that if you're an Android developer, that the Google Play services will have the TensorFlow Lite runtime bundled with it. Of course, if you're an iOS developer, there's no Google Play services for that. You will still have to bundle the TensorFlow Lite runtime with your app. So then number two, and another particularly exciting one, and one of the things that we've heard from many developers is that there's too many model types. So typically, if you train a model on your workstation or on something like Google Colab, you'll save that out as a saved model format. There's a number of different formats. Keras has something called H5. Saved model is what we tried to standardize on. And the idea is, if you're running it on the web, you're running on the cloud, you can go off of the saved model. If you want to put it onto a mobile device like Android or iOS, you got to convert it to the .tf Lite format. And if you wanted to put it onto the web so that you can run it within a browser using TensorFlow.js, you then had to further convert that into JSON. So one of the things that we've been doing is we've been working really hard to remove that final conversion step and to try to standardize on portable models, for want of a better term, using the .tf Lite format. So when you create a model and you convert it to .tf Lite to be able to run it on Android or iOS or increasingly embedded systems, now the idea is that that single model type will run on the web. If you're already a TensorFlow user and you're familiar with something called TensorFlow Hub, there are many models on TensorFlow Hub in the .tf Lite format. And we've had so much feedback from JavaScript developers who want to be able to use those models, but they had trouble converting them. So the goal here is to using mobile optimized TF Lite models, using WebAssembly, you'll be able to run your TF Lite models directly in the browser. This says on the web. Strictly, I mean, I keep telling them off to saying on the web. Strictly, what we're saying here is it really means in the browser using JavaScript. And so again, it's one way of reducing the amount of work that you have to do if you want to reach all of these platforms. It's also one way of expanding your boundaries if you're a JavaScript developer, because you'll be able to take advantage of the TF Lite models, like I mentioned, that are available on TensorFlow Hub. And we've had a lot of complaints that there's a lot more of them than there are JavaScript models. And this is the goal of this, is to really start bridging that gap. Okay, announcement number 3 came in the keynote yesterday, and it's one that we're particularly excited about if you're more on the enterprise side of the spectrum, and that's we launched a new product called Vertex AI. And Vertex AI is really the unified cloud AI platform. So the goal with Vertex AI is to really help you build and scale models faster, to be able to deploy them in a scalable environment on the cloud. It's generally for more complex workloads. So for example, you're not going to create your own model architecture using Vertex AI. It will actually use AutoML to be able to derive the best architecture for you, which means it's a little bit slower at training models, but it's finding the best architecture for you that you can deploy your model with. If you get a chance, take a look at the developer keynotes that was aired yesterday. And it will really show you the end-to-end workflow and how this will work. And I mean, I'll summarize it, but one of the things that we built for JavaScript developers was an example of how to do comment spam detection in the browser. So we created a very simple model based off of comment spam that actually hit my personal blog. And so it's just really a toy model. And we showed you, and we've built a learning path to show you how you can create that in JavaScript. You can build a model, it will run in the browser. You can use our existing model to do that, and you can extend that with transfer learning if you have your own data and your own comment spam that you want to train it for, and all of those kind of things. And it works really well. But then it's a case of, with a scenario like comment spam, is that it's a constant arms race to keep ahead of the spammers. So something like Vertex AI it's a paid service, but what you're going to get out of this is that instead of you trying to figure out the architecture, or you training a model yourself, or continually retraining a model, with Vertex AI, you've got all of that pipeline management. You'll have AutoML to derive the best model architecture, train the model for you. And as you have new data coming in, for example, you've labeled new categories of spam that got through your filter, you can add them to the system. It can continually retrain models. It can continually pipeline them and all of these kind of things. So the idea is really Vertex AI is if you want to go beyond the open source TensorFlow ecosystem and you want to have a professional tool that can be used for training models with AutoML, deploying them, managing them, all of those kind of things, it's a pretty interesting release. Okay, so the number 4, and this was one of the things that I mentioned earlier on when I was talking about the comment spam, is that one of the problems that we heard from software developers is that it's really complex. We have TensorFlow Lite, TensorFlow JS, Hub, MLKit, MediaPipe, Firebase, Cloud, all of these different things. And a lot of developers will get confused knowing where to start. Should I start with MLKit? Should I start with TensorFlow Lite? Do I need both Lite and JS? And all of these kind of questions. So what we wanted to do was launch a single website that spans multiple Google groups. There's always a problem when you work for a big software company. Like I work for Google now, I used to work for Microsoft and some others, that you've got different orgs all shipping different things at different times, and it can lead to developer confusion. So what we really wanted to do was come up with a single page where it's built by people from all of the different groups, from TensorFlow, from MLKit, from Android, from Cloud, and from others, with the idea being that let's figure out the best set of solutions for developers and come up with opinionated learning paths so that if a developer wants to do a specific solution, we'll take them end to end in how to do that. And for V1 of this, we picked the 6 most common things that developers generally want to build, and that's 5 of them were in mobile. So it's image classification on mobile, text classification, audio classification, where you can like detect sounds in your environment. In this case, it's a birdsong identifier. There was object detection, so classic, not just detecting what's in the image, but drawing a bounding box around it. And then there was visual product search, which is a really exciting one, where the idea is that if you have a catalog, for example, and you take a photograph of a page in the catalog that has clothing in it, then object detection will detect the clothing and give you a bounding box. But then the idea is like, well, what if you touch on that piece of clothing, that you'd want to slice that part out of the image and pass that to a back-end service to be able to search for things that match that. So the learning path takes you end to end for all of that for dress shopping. So you see an example of there's a back-end service. You'll learn how to build that back-end service, which is a catalog of dresses. And then there's an app that you take a photograph of a page of dresses, you pick a dress, and then you'll get recommendations from the catalog, that kind of thing. And then the 6th one is the web-based, and it's the comment spam that I mentioned. So the idea behind this site, g.co/on-device-ml, is really to be that one-stop shop for developers to navigate the myriad of different technologies from Google that will help you to build for Android, for iOS, or for the web. We really wanted it to be as agnostic as possible from each group's individual technology. So the TensorFlow folks aren't selling TensorFlow, the MLKit folks aren't selling that. We got together and we said, in a particular scenario, here's the best possible solution. Here's the easiest way for developers, and we wanted to teach that. So that's the idea behind this site. It launched yesterday, and we're going to continue growing that with extra learning pathways and extra stuff to be in there based on the feedback that we get from you about what it is that you want to see. Okay, update number 5 was if you use MLKit, we've had a number of new model types that are in this. If you're not familiar with MLKit, the goal behind MLKit is it uses TensorFlow Lite under the hood. But what MLKit does is it ships models for common scenarios with a high-level asynchronous API that's much easier to program against. You're not getting down into low-level bits and bytes and dealing with tensors and that kind of thing. And it's also asynchronous. If you've ever used Firebase, you're probably familiar with Firebase's asynchronous high-level programming model. MLKit, splintered off from Firebase, keeps that programming model. And one of the things that we announced yesterday were a number of new model types, including digital ink recognition, pose detection, selfie segmentation, and entity extraction. So these shipped as of yesterday, and we're continuing to add to MLKit all the time. And there's a talk at Google I/O about MLKit, so you can learn how to use these. Number 6 then was for mobile developers, was profilers, so that you can look at your app, you can understand how your app works, and you can start profiling it. So in Android 10 Plus and in Android Studio, there's a new profiler called Perfetto. And so the goal was to allow Perfetto to work well with TensorFlow-like models so that you can start profiling how the model works, how's it going to work. Like, for example, if it's an image classifier, how fast is it going to be? How accurate is it going to be? How will it deal with different types of images and that kind of thing? And of course, for iOS, then we've also been working on Xcode profiler integration using signposts. So the whole idea, again, is that if you're building apps and you're using TensorFlow.Lite and you want to deploy them to the App Store, you want to be able to do proper profiling on them. You want to make sure that they're not eating battery unnecessarily, which could get you kicked out of the App Store and those kind of things. So the team has been hard at work to get the iOS profiler working. Okay, number 7 is, if you're familiar with TFX, we're really excited to announce the launch of TFX 1.0. So TFX is something, end-to-end platform for deploying production ML pipelines. Now, this might sound very similar to Vertex AI that I was talking about earlier on, and in some ways it is, but TFX is the complete and pure open source version of this. So it's a set of, not an open source version of Vertex, but an open source set of code that will allow you to do production ML pipelines. So it's TFX stands for TensorFlow Extended. So everything from model management to model serving and all of those kind of things are in TFX. And we're really excited to announce that we're actually able to release TFX 1.0 this week. So then number 8 is when you're thinking about things like ethics, bias, responsible AI, and those kind of things, of course, it's very important, and it's something that has to be part of your entire journey. And often when we're doing AI systems and we want to think about responsible AI, you know, the spotlight turns on the data, and the spotlight only turns on the data. And we want to realize, and we want to help people realize that while the data is a huge part of being able to introduce bad things into your AI, it's not the only thing. And so the goal that came out of our People in AI research group is a set of guidelines and a set of guidebooks and a set of tools that will allow you to effectively build AI systems responsibly. A lot of these tools, of course, are for your data, but they're not entirely for your data. But there is one data tool called Know Your Data, KYD, that we released just yesterday as well, that allows you to slice and dice your data and understand it so you can learn how your data may lead to biases. And I don't have a slide for it here, sorry, but I mean, I can tell one thing. I was just playing with the tool myself this morning, and I built a data set. If you've done any of my Coursera courses, you're probably familiar with a data set called Horses or Humans. And this data set has a number of images of horses, a number of images of humans that were all generated using CGI. And the idea is just for you to learn how to build a basic image classifier that can tell the difference between a horse and a human. So I started using the Know Your Data on this. And one of the things, for example, Know Your Data does is that if you have pictures of people, it will actually tell you how well it can pick out the face of the person in the picture. Now, I deliberately built the data set to have multiple skin colors. So the entire spectrum, you know, from the darkest to the lightest skin tones. But what I was really surprised by was that when I passed this data set through the Know Your Data tool this morning, I realized that many of the darker skin tones, the Know Your Data tool wasn't able to detect faces in that. And then I realized anybody building something using this data set are probably introducing a bias, or they're probably not getting the best possible results because of this flaw in my data. So it gave me the action item that I have to build Horses or Humans version 2, but that's going to take me a little while. But these are the kind of things that the People in AI guidebook and the set of tools from the Pair team will bring you. Definitely worth investing in, definitely worth taking a look at. So number 9 is decision trees. So we did ship TensorFlow 2.5 just last week prior to I/O. And one of the things that came out of this was to be able to make decision trees easy. Whoops, I don't have the source code for that, sorry. But we all know what decision trees are and decision forests, how we can merge decision trees together to come up with voting. Coding for this can be quite complex. So we put together some samples, and there's a talk at Google I/O. If you go to youtube.com/TensorFlow, you'll find the talk where Josh Gordon, my colleague, will go through decision trees and how to code them using Keras. And then finally, number 10, last but not least, is one of the things that we've heard is like to bring community closer together. A lot of folks wanted an official TensorFlow forum. So we've launched that. The goal is that, you know, it's the constructive conversation, support, inspiration, all of those kind of things. All of the Googlers who work on TensorFlow have been encouraged to participate in this forum. So please feel free to go there, ask questions, share best practices, all of those kind of things. And you'll see it's at discuss.tensorflow.org. So that's it for my roundup of the 10 of the top things that we've announced at Google I/O. I'm going to stop sharing my screen now, and I'm happy to answer any questions that anybody has.
Awesome. Thank you so much. This was great. Great to see. I'm especially like very surprised to see like a few of the things that you mentioned. Very, very exciting, I think, from Google side. Yes, to the audience, please do feel free to ask questions. We still have like a bit of time. We planned actually a bit of time for QA. So do ask questions here on the Zoom chat, on Slack. And I think it would be also okay if you prefer to speak up, please do. And let me start with a few questions around one of the main trends is, and maybe also like, you know, one of the things that you've been working on is obviously productionizing machine learning. And it's very exciting to hear that like to think beyond the ML developer and going towards the software engineer, right? And teaching them the right skills in order to even commoditize, I would say, machine learning. And what would you say, like in that kind of environment, especially also thinking about ML ops and industry, ML productionizing, machine learning, large scale modeling, what are some of the key skills that a software engineer should kind of, you know, acquire in order to get into the field?
That's a great question, and there's many, too many to list. So I think one of the things that I would say is that to try and help solve this problem, we've been working with the folks at deeplearning.ai, so Andrew Ng and his team, to come up with a set of courses and a specialization all around MLOps. And our vision has been to try to make this as agnostic as possible to different vendors. So we do cover Amazon and Microsoft as well as Google. And Andrew, one of my colleagues, his name is Robert Crow, and I are teaching these courses. I think the first couple of courses I've already launched. And so the goal there is to really go end to end to help you in all of the skills that you would need to be able to do MLOps. So everything, not just from building models, but to understanding your data, understanding potential biases, optimizing your models, coming up with pipelines if you support multiple models, being able to do the conversion if you want to use mobile and web and cloud and all of those kind of things. Looking at deploying, looking at managing, and just about everything end to end that any system architect, forgetting machine learning for a second, but any system architect who needs to deploy new systems into a data center, the amount of skills that they need to learn, how the data center works and all of those kind of things, and then layer models on top of that is really the vision of what we're trying to achieve here. It's an enormous course, so it's taking us some time. And but I would say definitely go check that out. So deeplearning.ai, the company, they publish it on Coursera, the same folks that we worked with for my Coursera courses. And we're really excited to get that rolled out over the summer. And I would say that that would be the best source for learning the set of skills that you would need to learn.
That's super interesting, super exciting. And you said something very interesting right now. You said, well, forget about machine learning. And this is also something that I have the feeling that, companies like Google, they're making it so easy to build models. Like even for myself, I'm not a computer scientist, I'm not an engineer, I'm a computational linguist. And it's so easy for me through your ecosystem, through Keras, through TensorFlow to build models. And then thinking about ML ops and also productionizing machine learning, it almost feels like, yeah, as I said before, right? Machine learning is almost commoditized, right? Even with AutoML that you mentioned in your talk, right? It's becoming easier and easier. And Andrew Ng, for instance, I think I saw one talk where he talked about ML ops, and they're very data centric, right? So things like all of a sudden it shifts the focus from machine learning to either, or maybe even both, to data and to, you know, making everything work at scale from the ML ops perspective. Would you agree, or would you say it's a trade-off?
In general, I agree. And I think the vision for how machine learning can be successful for all of us is when we realize that machine learning shouldn't be a special, separate skill, but just a general part of every developer's toolbox. The only analogy I can think of is that, you know, not that long ago, once upon a time, you had developers who wrote code, and you had a separate breed of developers who created databases and wrote things like stored procedures or SQL queries or those kind of things that, you know, would work alongside the web or the enterprise developer, but was a completely separate skill set. Often now you don't see that. The general developer has the data skill sets themselves. I don't know if it's a good analogy, but it's the one that I'm trying to think of when, you know, putting something like this together. So the idea here, and what we're really trying to drive towards, is that while there's always going to be room for ML specialists and for people who have deep expertise in ML, we have to realize that the global market for them is probably in the hundreds of thousands or low millions, whereas the global market for software developers is growing rapidly. You know, it's in the tens of millions, and I said at the beginning that I estimated 30 million, but given that last year WWDC, Tim Cook said there were 28 million Apple developers alone, we're probably closer to 50 million or more software developers at the moment. So the idea is that most of those aren't going to become ML only people. So we want them to have ML skills in their toolbox the same way as they have, you know, programming language skills, database skills, styling skills, or those kind of things. They may not be the deep expert in these things, but in order for the industry to succeed with machine learning, we want as many of them as possible to have the machine learning skills. So that's really the direction that we're driving towards on our developer relations team.
That's incredible, incredible numbers. Yeah, absolutely. We have a few questions from the audience, a bit more specific questions. So Jose is asking about Lambda, which was presented in the main keynote. When will it be available through MLKit? And he can't wait to get his hands on.
I can't wait to get my hands on it either, Jose. So Lambda is one of the new language-based search things that we've been working on. It's very much a research project at the moment. So there's no timeline at the moment for when there'll be a public API for that. And even once there's a public API, there's no timeline beyond that for when it will be available in MLKit. It is a very large language model. So we showed that at the consumer keynote so that we could have like a little bit of a peek at the future of what's going to be possible. And if you haven't watched the keynote, at least, you know, Google for a conversation with the planet Pluto, where they actually demoed that, where it was built using Lambda, where first of all, Google mentioned that Pluto is a planet again. Sometimes it's a planet, sometimes it isn't, but I guess we've chosen our side. And then using Lambda, some research scientists built, you know, this demo of that. But Lambda for non-Google and for public consumption is still some time off, and we don't have a date for that yet, I'm afraid. But as soon as we do, I'm going to be one of the most excited to use it and to share it with the world. And then Cataluna84 asks, are there optimization tools available for making model inference faster, like optimizing repeated inception blocks and those kind of things? So there's two answers to that question. The first one is in AutoML. So the idea behind AutoML is to do a neural architecture search for which, and you can define the desired parameters of that neural architecture search. One of those desired parameters could be making inference faster. So if you're using something like the Vertex that I mentioned earlier on, you get that effectively for free. You're just going to give it the data, you're going to give it the target that you want, and it will figure out the appropriate architecture to be able to do that. That's one answer to that. The second answer to that is there's something called a Keras tuner, which you can use to do a basic neural architecture search or hyperparameter optimization. And I think you could use that if you're smart about how you define your model. So if you have like, you know, a separate function with the inception blocks within it, that you could then have a loop through those, and then you could do a hyperparameter search on how many of them to do. that type of thing to be able to get to it. And then the third one is not so much for your scenario that you mentioned around inception blocks, but if you are converting your tool to mobile, then there's something called the Model Optimization Toolkit, which does things like quantization of the model, pruning of the model, and various other things automatically for you to shrink your model without losing too much of your accuracy of your model. So optimization wise, those would be the three things that I'd say that would be the main things that we're working on. Okay, so Colin asked, over the years, I've seen improvements in statistical software enabling less and less skillful use of statistical modeling to the point where students just cut and paste modeling results entirely, acritically. Do I see this in ML as well? And if so, what steps do we take to guard against this? So that's a great question. I would say that, like with any other code, for very common scenarios, you're going to be stack overflowing, cutting and pasting code. Whether that's a model architecture, whether that's feature engineering, or those kind of things, for the very general things that everybody's doing. So for example, if everybody's building an image classifier, why would you need to learn the code to be able to build the best possible image classifier? It's when you start going beyond the basics, just like with any other code, that cut and pasted coding will only get you so far, and you have to have the domain expertise. You have to tweak that code to fit whatever your specific domain is, whatever specific problem you're trying to solve is, and the cut and paste code might get you 50% of the way there. So I see ML kind of emerging that way when it comes to people creating models in code, doing the feature engineering and everything else that you're like writing any kind of code for. And then Horses versus Humans version 2.0, do I have any guesses how far you could get with a quick and dirty data augmentation hack like adjusting skin colors? I don't yet. It's one of the things I would look at. I have been playing with data augmentation using that data set. And I actually deliberately designed that data set to teach data augmentation. But the surprise that I got today was, when I designed it, like I mentioned, with some that have quite dark skins, that the know your data didn't even detect that as a face. And although that being said, there was an example in the data set where there was a very light skinned person and the face was going face onto the camera, and know your data didn't detect that as a face either. So it might be a bug in the know your data tool, which I filed against the team. But I think, data augmentation is something that can certainly help there. But if we take a step back and we think about it, it's like, we're still reinforcing a bias if we're saying that a person of dark skin has to be recognized through data augmentation and a person of light skin doesn't. So there's clearly a problem there. While the data augmentation might be a fix to it, we still want to make sure that we, do the right thing by the data and do the right thing by our users. Okay, let's see. It just scrolled up, so let me take a quick look. Okay. Could you also talk about federated learning and differential privacy tools? So these are both things that we're really hard at work on. We hadn't had any major announcements around these at I/O. We do have something called TF Federated in TensorFlow that we do want to be able to release to the public soon. We don't have a date for that yet. The idea behind that one is right now you can build federated learning with that, but you can't deploy it to mobile devices. You can only simulate it in a development tool such as Colab. We do want to get that in the hands of software developers as soon as possible so that they can start looking at federated learning on device. But there's a whole host of challenges there that we're still working on. And for differential privacy, I do believe TensorFlow 2.5 released a couple of new differential privacy tools, but I'm not too familiar with them. I would say just check out the blog post for details on that. Okay, so Giriraj, forgive me if I mispronounce your name, asked, I would like to know if there's specific hardware Google's working on for Android devices for the upcoming Pixel lineup, which will provide leverage to Google in AI. I mean, I can't speculate about upcoming devices, but one of the things that we have been working hard on with TensorFlow Lite is so that GPU-based inference will be faster. And Android itself has neural network APIs that you can also take advantage of. So the vision here for Android developers is if you don't have a GPU and you don't have access to the neural network API, you can still do inference on the CPU, But if you do have access to both of these, there's a GPU delegate and the neural network API that will allow you to do it much more quickly. But when it comes to new specific hardware that we're working on for upcoming ones, we can't comment on that yet. We have to wait for the announcements around any potential upcoming Pixel before we can talk about that. BJ asks, what general recent trends in ML have been exciting, both in terms of AI in practice and research? That's a really good one. I think for me personally, the general recent trends that I'm most excited about are when AI gets smaller. A lot of the attention has been on things like GPT-3 and Lambda and MUM, where AI is huge. And of course, there's huge implications of that we're all very familiar with. But where I'm particularly interested personally is when AI gets smaller. And I teach a course at Harvard on TinyML. And we're beginning to see some of the implementations and things that people have done with TinyML using models that they just weren't previously possible. And these are the kind of things that get AI into the hands of millions of people in a way that can be life-changing. And so I think anything where AI gets smaller and being able to do things on smaller devices, for me particularly, is the most exciting. If you get a chance, there was a guy called Jason who was a drummer, and there's a video about him at Google I/O where he lost an arm, and he after losing his arm, he wanted to get back to drumming, and he just had a basic prosthetic with a drumstick on it. But if you've ever drummed, he couldn't get the actual timing, he couldn't get the sensitivity. He was just bashing the drum with this thing. So he worked with some folks at, I believe it was Georgia Tech University, Harvard, and Google, and they've built a device that he would twitch his arm in the way that he would have previously twitched it, to be able to move the drumstick gently. And the device learned from these twitches how he would want to drum. And then the prosthetic arm has almost like a little robot swivel on it, so that when he twitches his arm appropriately, he gets that sensitivity in drumming. And it actually brought back his ability to drum. And this is only possible through something like a TinyML type of thing. And I'd say, those are the things that totally excite me. Look out for that video. You should find it on youtube.com/TensorFlow. Okay, so Shinde asked, thanks for the, whoops, it scrolled off. Thanks for the announcements. We heard about deploying models on apps or web. I would like to know your thoughts on edge hardware. What's our direction to deploy models on hardware devices or Coral devices? Well, yeah, just as I was talking about earlier on. So we have TensorFlow Lite will run on many edge devices, on small things like Raspberry Pi, on Coral, or you can accelerate them using Coral devices. We also have something called TensorFlow Lite Micro, which gets it even smaller for being able to run on microcontrollers. I think that journey is really only just beginning, and I'm particularly excited by that one. Jose asked, love your courses. Thank you. Currently taking the new ML Ops and where I take part. Do I have any other course in preparation? As of now, I'm doing the deployment parts of the ML Ops course, so to teach you how to deploy models to the web and to the cloud. I'm working also with the Harvard folks that we did TinyML with to be able to extend that course. But that's it for the moment. I've been busy with Google I/O, and I've also been busy writing a book on ODML, on-device machine learning, which I've just finished writing, so I'm hoping to get it published in the next couple of months. Okay, Francisco asked, whoops, it scrolled off. Where'd you go? AutoML versus handmade models. At my organization, we're looking at AutoML as a benchmark generation tool so that data scientists can have a direction to find improvements. What's my take on AutoML as production ready versus being a starting point? I think my answer there is it really depends. I think AutoML is, if I didn't work for Google, I would say it's the kind of thing that it's hard to trust because you don't have that fine-grained control over defining your model and knowing what it does. I mean, it has to earn its trust by you creating a model, testing it extensively, seeing how well that it works, seeing the results out of that model and all of those kind of things. So, if I wasn't a Googler and I was building models for my organization, that would be my first thing around AutoML is that, any kind of automated tool can be incredibly useful, can be incredibly powerful, can get us to where we want to go, but don't trust the marketing. We got to try it and we got to burn a lot of cycles and burn a lot of calories, like experimenting with it, testing with it, and those kind of things. And that would be my first take there on that versus, is it production ready? Well, you got to try it out for yourself. We've tried it on many different cases, many different data sets. We found that it's amazing, but that doesn't mean it's going to work for yours. And I would say anybody, the advice would be to do diligence on that. And then in addition to that, there's like an automated system is only going to be able to do what an automated system does. True innovation comes from being able to have that insights to your data or your insights to the problem that you want to solve that an automated system may not be able to do. So it's definitely worth doing your due diligence on a manual one as well. Okay, Colin asked, low priority if there's time. Oh, we got 10 more minutes. Following up to the preventing a critical control PML, best tools for unit testing ML models. There's a unit test Python message package. Is there anything else? I don't really know, to be honest. I generally do all of my testing of models without using any kind of tooling whatsoever. I just write Python scripts to be able to test them, or I even do things like a Keras tuner to, first of all, do like a basic hyperparameter search to find the best possible model, and then throw a whole bunch of tests of that I manually wrote. So I'm not the person to ask for unit testing, sorry. So JB, what do you think about teaching AI and ML to school kids? You're an awesome teacher, thank you. Do you have an intention to create a course for AI and ML for school kids? Funny you should ask, but I'm actually chatting with the Harvard people about that at the moment. It's one of the things we're thinking about. Is there was some way of doing an AI ML for not just for software developers, but for everybody. I can't use the term AI for everybody because Andrew did that. Andrew Ng has a brilliant course on that. But we're looking at saying, is there a way that we can teach AI and ML, the basic concepts so that people can understand what it is without having a technical background? So talking about that with the Harvard folks at the moment, and may start working on that later in the summer, but to be determined. And I think that's all of the questions. Forgive me if I've skipped you, or if I've skipped you, just post it in the window again. But is that everybody? I think so. Oh, so BJ asked, to go in the reverse of what you covered in the presentation, how much should ML practitioners know about web app development? Great question. I think it depends on what you want your career to be. I think if you're an existing ML practitioner, you're one of the few 100,000 or maybe low millions, which gives you great value. But I think, as companies are going to be investing more and more in building the kind of apps that change the world. Let me give an example. We had one app that we showcased in the keynote. It's not publicly available yet, but it was a dermatology app, so that on an Android phone, you could take photographs of your skin and you could determine potential risk of skin cancer. Those type of apps don't need an ML engineer to be able to build them. The type of model, the type of classification model there, it's going to be advanced, but it doesn't need somebody who's a dedicated ML engineer to do that. And a good software developer who knows some ML, who can build models, will be able to build that type of app. And those are the folks that I see being the great wave of the future to be able to bring ML to billions. So I would say, if you are an ML practitioner, but you want to have that kind of impact, then I certainly would recommend learning web and or mobile development. Let's see. Okay, Monisha asked, there's a Python-based model actually runs on the production considering speed of execution and latency issues. So if you create a TensorFlow model that runs on TensorFlow serving, you are actually going to be doing the invocation of that using generally Python. It also supports C++ if you want to go for speed. If you create the model in TensorFlow and you're running that as a .tf Lite model on Android or iOS, then whatever the appropriate language on those, on Android it's Java and Kotlin, on iOS it's Objective-C or Swift, would be the language that you're actually using there. And if you're doing tiny ML models, that's generally C++ on an embedded system. Yep, somebody just posted the link to the skin condition thing via smartphone photos. And I think that's a great example of like where I'm talking about the future for me of huge value in ML engineering is in these small focus scenarios that, somebody who has studied ML for a year or less should be able to build an effective model to do that, maybe not the optimal model, but an effective model to do that, and then be able to wrap that in an app so that anybody can use it, as opposed to these large research-oriented models that are only within a particular cloud infrastructure and of use for relatively few people. What do you think about teaching? Oh no, somebody asked. I did answer that one already. There's something cooking about graph databases, neural networks at Google. The applications are very exciting in a lot of various fields, and Neo4j for instance provides really sexy tools with lots of machine learning applications. Is Google working on something in-house? So we're not really allowed to share anything private that's going on in-house until it's published and made public. So of course, we're continuing to work in research, a lot in graph databases, a lot of new neural network types. I would say just watch our research org for details there. They're publishing papers on an almost daily basis. And then as those papers come out around these things, that's when we'll be able to talk about it. But for confidentiality and potential IP reasons, we can't really talk about it publicly until it's published. Okay, I guess that's it for questions. So just want to say thank you, everybody. Arigato gozaimashita. Thanks for hosting me for this hour. Before the pandemic, I was lucky enough to be able to travel to Tokyo 2 to 3 times a year. Hopefully I'll be able to do that again next year, and we'll see. My book, The AI and Machine Learning for Coders, a Japanese publisher bought the rights to it a couple of months ago, so hopefully there'll be a Japanese version of it in bookstores soon. And if there is, I'm looking forward to being able to visit Tokyo and seeing it for myself.